In this video, we're going to look at Cambridge International AS and A-Level Mathematics 9709, Pure Mathematics 1, Paper 1-1 from May-June 2025. Solve the equation. Here we have 6 sine theta is equal to 1 plus 2 over sine theta. So we can rewrite our equation down here. Now, if you battle with trigonometric ratios in your equation, you can substitute the ratios for x. So let's say let sine theta be x, and our equation becomes 6x is equal to 1 plus 2 over x. Now, to solve for x, we don't want an x term in the denominator of the fraction, so we need to multiply it out. And we're going to get 6x squared is equal to x plus 2. Now we have a quadratic, so let's move our x terms to the left, and we get 6x squared minus x minus 2 is equal to 0. In your exam, when working with a quadratic, the best way to solve for x is to use the quadratic formula. X is equal to negative b plus or minus b squared minus 4ac all under a square root all over 2a. In this case, we can say x is equal to, b is negative 1, so negative b becomes 1, plus minus b squared, which is negative 1 squared, minus 4, multiplied by a, which is 6, multiplied by c, which is negative 2. Close the bracket, all under a root, all over 2 multiplied by a, which is 6. So we get a denominator of 12. Now, because of the plus and minus sign, you cannot put the formula straight into your calculator. But the easiest thing to do is to find the values under the root. Now you can take your calculator, so open a bracket, you can say negative 1 squared minus 4 multiplied by 6 multiplied by negative 2 is equal to 49. Let's square root that, and we get 7. So our formula becomes x is equal to 1 plus or minus 7 over 12. If we consider the plus sign in the numerator, we get 1 plus 7, which is 8, over 12. So x is equal to 8 over 12. Simplify, and we see that x is equal to 2 over 3. If we consider the minus sign in the numerator, 1 minus 7 is negative 6 over 12, gives us negative 1 over 2. So x could be equal to negative 1 over 2. Let's make some space and rewrite our x values over here. X is equal to 2 over 3, or x is equal to negative 1 over 2. But remember, we are not solving for x. We are solving for sine theta. So now, instead of x, we can say sine theta is equal to 2 over 3, or sine theta is equal to negative 1 over 2. Now you can take your calculator, and we say shift sine 2 over 3, close the bracket, is equal to 41,81 degrees. This is our value for theta, 41,81 degrees. Now let's find theta when sine theta is negative 1 over 2. So we can say shift sine, negative 1 over 2, close the bracket, is equal to negative 30. So theta is equal to negative 30 degrees. But please be careful. Your calculator will only give you values of theta between negative and positive 90 degrees. But in this question, we need to find values of theta between negative and positive 180 degrees. So let's make some space, and we're going to rewrite our values for theta up here. The best way to find all the possible values of theta is to draw a graph. So let's put in our axes from negative to positive 180 degrees. Sine theta has a y-intercept at the origin, its x-intercepts at 180 and negative 180 degrees. It has a maximum turning point at 90 degrees and a minimum turning point at negative 90 degrees. So your graph should look like this. In your exam, your sketch does not need to be to scale. It just needs to give you a general idea of what you're working with. Let's start where theta is 41,81 degrees. That should sit around about here. And I'm going to make a note of this up here. All the values of theta that we need to consider have the same y-coordinate. So we can draw a horizontal line through our red dot and see where else it touches the sketch. And we can see that we have another point over here. Now, points with the same y-coordinate are the same distance away from the turning points and from the x-intercepts. So in this case, this point over here is 41,81 degrees to the left of 180. So let's take our calculator and we can say 180 minus 41,81 degrees is equal to 138,19. This is a value of theta that we need to consider. So let's put this in over here. Now let's plot our point for negative 30 degrees. It'll sit down here. Let's make a note as well. Now we can draw a horizontal line. And we see that we have another point on our graph over here. Negative 30 degrees lies 30 degrees to the left of the origin, which means this point lies 30 degrees to the right of negative 180. So we can say negative 180 degrees plus 30 is equal to negative 150 degrees. This is the x-coordinate of this point. And now we have 4 values of theta for our answer. So we can say that theta is equal to negative 150 degrees, negative 30 degrees, 41,81 degrees, and 138,19 degrees. These are all the values of theta. The equation of the curve is such that dy over dx is equal to 4 multiplied by the bracket 2x minus 5 cubed minus 9x to the power of 1 over 2. The curve passes through the point A with coordinates 4 and negative 11 over 2. Find the gradient of the normal to the curve at point A. The normal is perpendicular to the tangent. So to find the gradient for the normal, we first have to find the gradient for the tangent. So let's rewrite our equation for the derivative over here. dy over dx is equal to 4 multiplied by 2x minus 5 cubed minus 9x with an exponent of 1 over 2. The curve passes to the point A with an x-coordinate of 4. So to find the gradient of the tangent at that point, we substitute 4 into our x values. So we say 4, open a bracket, 2 multiplied by 4, minus 5, close the bracket, cubed, minus 9, multiplied by 4, with an exponent of 1 over 2. And you can put this entire equation into your calculator. So we're going to say 4, open a bracket, 2 multiplied by 4, minus 5, close the bracket, cubed, minus 9, multiplied by 4, with an exponent of 1 over 2. And we get 90. This is the gradient of the tangent. And a whole number can be written over a denominator of 1. To find the gradient of the normal, all we do is turn the fraction upside down and change the sign. So in this case, I can say the gradient of the normal is equal to negative 1 over 90. Find the equation of the curve. Because we have the brackets in our derivative, the best way to integrate is to use the reverse chain rule. So let's start by making our bracket t. So we can say t is equal to 2x minus 5. So the equation for the derivative now becomes dy over dx, we can leave it like that, is equal to 4t cubed minus 9x with an exponent of 1 over 2. Now we need to differentiate this equation. dt over dx is equal to 2. Now we can integrate this equation. We can say y will be equal to 4t with exponents of 3 plus 1, which is 4, all over 4. Because we have an original equation in terms of x, we do not want to integrate in terms of t. So to integrate this equation, we now divide this term by 2. So I'm going to say divided by 2. Now we can integrate the rest, and we say minus 9. X with an exponent of 1 over 2 gives us an exponent of 3 over 2, all over 3 over 2. And now we can simplify. We get y is equal to, the 4's cancel, and we get t with an exponent of 4 divided by 2 comes over 2, minus 9 divided by 3 is 3, multiplied by 2 gives us 6. We get 6x with an exponent of 3 over 2 plus c. Now we can substitute our brackets back into t. We can say y is equal to, open our bracket, 2x minus 5 with an exponent of 4. Squeeze this in here, all over 2, minus 6x with an exponent of 3 over 2 plus c. But we still need the value of c. So let's make some space, and I'm quickly just going to rewrite our equation up here. 2x minus 5 with an exponent of 4 all over 2 minus 6x with an exponent of 3 over 2 plus c. To find the value of c, we can substitute the coordinates of our given point into the x and y values. So we're going to say negative 11 over 2 is equal to 2 multiplied by 4 minus 5, close the bracket, with an exponent of 4 over 2 minus 6 multiplied by 4 with an exponent of 3 over 2 plus c. Now we have negative 11 over 2, and we can put this fraction into our calculator. We're going to have 2 multiplied by 4 minus 5 with an exponent of 4 divided by 2 gives us 81 over 2. So this becomes 81 over 2 minus, take your calculator, 4 with an exponent of 3 over 2 multiplied by 6 is 48. We have 81 over 2 minus 48 plus c. Now we can move everything to the left. So let's take your calculator again. We have negative 11 over 2 minus 81 over 2 plus 48 is equal to 2. So c is equal to 2. The third term of a geometric progression is 18, and the sum of the first three terms is 26. It is given that the common ratio is negative. Find the 10th term of the progression. Give your answer correct to 3 significant figures. Now, when working with a geometric progression, to find a term, we use the formula Tn is equal to a multiplied by r with an exponent of n minus 1. And we can use this to help us find the value of a and the value of r. The question says that the third term is 18. This means that ar squared is equal to 18. It also tells us that the sum of the first three terms is 26. Now, you can use the formula for the sum of a geometric progression, but this becomes very intricate in this question. So an easier way is to consider the first, the second, and the third terms. Our first term is a. Our second term is ar. You can say plus ar. We know that our third term is 18. You can say plus 18 is equal to 26. Now we have two equations with a and with r, and we can use these to find our unknown values. On the right, let's move 18 to the right, and we can get a plus ar is equal to 26 minus 18, which is 8. Now on the left, we can take a out as a common factor, and we get a, open a bracket, 1 plus r is equal to 8. Let's make a the subject. We can say a is equal to 8 over 1 plus r. On the left, let's make a the subject as well. We can say a is equal to 18 over r squared. A is the first term in the progression, which means this value of a is equal to this value of a, which means our fractions are equal as well. So we can say 18 over r squared is equal to 8 over 1 plus r. And now we have an equation we can use to solve for r. Let's multiply our denominators out. We get 18 multiplied by 1 plus r is equal to 8r squared. Expand the bracket, 18 plus 18r is equal to 8r squared. Let's make some space. And I'm going to rewrite the equation up here. Let's have 8r squared. Move our r terms to the left. Get minus 18r minus 18 is equal to 0. Now we have a quadratic we can use to solve for r. In your exam, your time is limited, so you don't need to worry about simplifying these equations. You can put this straight into the quadratic formula. It's going to say r is equal to negative b. b is negative 18, so it becomes positive 18, plus or minus negative 18 squared minus 4 multiplied by a, which is 8, multiplied by c, which is negative 18, all under a square root, all over 2 multiplied by 8, which is 16. Now we can take a calculator, open a bracket, we're going to say negative 18 squared minus 4 multiplied by 8 multiplied by negative 18 is equal to 900 square root, and we get 30. So r is equal to 18 plus or minus 30 over 16. The question tells us that the common ratio r is negative, so we can only consider the minus sign in this fraction. So now take your calculator, 18 minus 30 divided by 16 gives us negative 3 over 4. This is our ratio for r. r is equal to negative 3 over 4. Now that we have the value of r, we can find the value of a. We know that a is equal to 18 over r squared. So now a is equal to 18 over negative 3 over 4 in a bracket squared. Take your calculator, 18 divided by, open a bracket, negative 3 over 4 squared is equal to 32. So a is equal to 32. Now that we have our a and r values, we can find the 10th term in the progression. For geometric, we say Tn is equal to a r with an exponent of n minus 1. We're looking for the 10th term, so say T10 is equal to a 32 multiplied by r negative 3 over 4 with an exponent of n minus 1. n is 10. 10 minus 1 gives us 9. Take your calculator, 32 multiplied by, open a bracket, negative 3 over 4 with an exponent of 9 is equal to, the question asks us to give our answer to 3 significant figures. So we can see the 10th term is equal to negative 2, comma 4, 0. Find the exact value of the sum to infinity of the progression. To find the sum, we say the sum to infinity is equal to a over 1 minus r. From part A, we know that a is 32 and r is equal to negative 3 over 4. So for the sum to infinity, we get 32 over 1 minus negative 3 over 4. We can put this into your calculator. 32 over 1 plus 3 over 4 is equal to 128 over 7. This is our sum to infinity. The diagram shows the curve with equation y is equal to 5x to the power of 3 over 2 minus 20x, and the line with equation y is equal to x minus 16. The x coordinates of the point of intersections of the curve and the line are 1 and 16. Find the area of the shaded region between the curve and the line. When we are looking for the shaded region between a curve and a line or two curves, the best place to start is to subtract the equation of the lower curve from the equation of the higher one. If you're not sure which curve or line lies above the other, take your pen and put it at the top of your diagram. Then draw a line down. The first curve or line that you touch is the higher one. So we can see that in this case, the line lies higher than the curve. So let's make some space. Now we need to subtract the equation of the curve from the equation of the line. The line takes an equation x minus 16. You can say x minus 16. Now we subtract the equation of the curve, this one over here. So we say minus 5x with an exponent of 3 over 2 minus negative 20x. And now we can add like terms. We have one term, negative 5x with an exponent of 3 over 2. We have x plus 20x, which gives us positive 21x minus the constant of 16. And this is now the equation that we need to integrate. And we're going to get negative 5x with an exponent 3 over 2 plus 1 becomes 5 over 2 all over 5 over 2 plus 21x squared minus, remember that your constant becomes your x term, so 16x. Now let's tidy this up. Negative 5 divided by 5 is 1, multiplied by 2, so we get negative 2x with an exponent of 5 over 2 plus 21 over 2x squared minus 16x. Next we need to substitute our x restrictions, 1 and 16, into the x values of our integrated equation. So let's start when x is 16. So we're going to have negative 2. Instead of x, say 16. Close the bracket, an exponent of 5 over 2 plus 21 over 2 multiplied by 16 squared minus 16 multiplied by 16. And you can put this entire thing into your calculator. We have negative 2 multiplied by 16 with an exponent of 5 over 2 plus 21 over 2 multiplied by 16 squared minus 16 multiplied by 16, and we get 384. Make note of this over here. Now we need to substitute 1 into x. We get negative 2 multiplied by 1, the exponent of 5 over 2, plus 21 over 2 multiplied by 1 squared minus 16 multiplied by 1. Remember that when you multiply any value by 1, it remains the same. So now we have negative 2 plus 21 over 2 minus 16. And we can put this into our calculator. Negative 2 plus 21 over 2 minus 16 is equal to negative 15 over 2. To find the shaded area, all we need to do is subtract the lower value we've just found from the higher one. Our higher value is 384 and our lower negative 15 over 2. So we can say 384 minus negative 15 over 2. Take your calculator. 384 plus 15 over 2 is equal to 783 over 2. This is our shaded area. Find the first three terms in ascending powers of x in the expansion of each of the following expressions. For part 1, we have the bracket 2 minus px with an exponent of 5. When expanding brackets, we can use the formula NCR multiplied by a with an exponent of n minus r multiplied by b with an exponent of r. N is the exponent outside the bracket. So in this case, n is 5. A is our first term. So in this case, a is 2. And b is the second term in the bracket. So b is equal to negative px. Now the question says, find the first three terms in ascending powers of x. This means that we need to find the constant when x is 0, the x term, and the x squared term. Now in the bracket, our b term is negative px. It is the only term with an x variable, which means that b with an exponent of r will give us our x term in the expansion. If r is 0, x will have an exponent of 0. So in order to find our constant, our x term and our x squared term, we need to expand the bracket for r values of 0, 1, and 2. So to find our constant, let's expand where r is 0. So we can start with NCR. N is 5. So we say 5, C, R is 0. Multiplied by A, which is 2. With an exponent of 5 minus 0, which is 5. Multiplied by negative px with an exponent of 0. When you are working with NCR and r is 0, the whole value of NCR will always be 1. So this is 1. Any bracket with an exponent of 0 is 1. So now we have 2 with an exponent of 5, which is 32, multiplied by 1, multiplied by 1 again, which means our constant is 32. Now let's find our x term, where r is 1. So we can say 5c1 multiplied by 2 with an exponent of 5 minus 1, which is 4, multiplied by negative px with an exponent of 1. When working with NCR, if r is 1, the value of NCR will be the value of n, which in this case is 5. You can say 5 multiplied by 2 with an exponent of 4, which is 16. 5 multiplied by 16 gives us 80. So we're going to get 80 multiplied by negative px, minus 80 px. This is the second term. For the third term, we can say 5c, r is now 2, multiplied by 2 with an exponent of 5 minus 2, which is 3, multiplied by negative p x squared. Now you can take your calculator, say 5c2, let's multiply this by 2 cubed, and we get 80. So we're going to get 80 multiplied by negative px squared, which becomes positive p squared x squared. Let's just tidy this up. And our third term is 80 p squared x squared. And we now have the first 3 terms in this expansion. Again, we need to find the first 3 terms in ascending powers of x. So we can use the formula NCR multiplied by a with an exponent of n minus r multiplied by b with an exponent of r. In this case, n is 4, a is 1, and b is negative 1 over 2x. Again, b is our x term, so we only need to consider our b term with an exponent of r. For our constant, r will be 0. For our x term, r will be 1. And for our square term, r will be 2. So let's find our first constant. So we're going to say NCR, n is 4, CR is 0, multiplied by a, which is 1, with an exponent of 4 minus 0, which is 4, multiplied by negative 1 over 2, x, with an exponent of r, which is 0. NCR has an r value of 0, so this is 1. 1 with any exponent is 1, and a bracket with an exponent of 0 is also 1. So our constant is 1. Now we can find our x term. We say 4c1 multiplied by 1 cubed multiplied by negative 1 over 2 x with an exponent of 1. 4c1 leaves us with 4 multiplied by 1 cubed, which is 1, multiplied by negative 1 over 2x. And we get negative 2x. This is our second term. Now we can find our third term. 4c2 multiplied by 1 squared multiplied by negative 1 over 2 x, close the bracket, squared. 1 squared is 1. So let's take our calculator so we can find NCR. We say 4c2 is equal to 6. So we have 6 multiplied by negative 1 over 2 squared gives us positive 1 over 4 x squared. Let's multiply this out, and our third term is 6 over 4 x squared. Part B says, given the coefficient of x squared in the expansion of the two brackets is 93, find the possible values of the constant p. Now, in a question like this, you can use your answers from part A to solve part B. In part A, we found the first 3 terms in the expansion of this bracket. Our first term was 32. Our second term, negative 80 px. And our third term, positive 80 p squared x squared. In part A2, we found the first 3 terms for the expansion of this bracket. 1 minus 2x plus 3 over 2 x squared. And we can use these terms to help us with this question. The question says the coefficient of the squared term is 93. So in this case, we need to expand the two brackets only for x squared terms. 32 multiplied by 1 gives us a constant. That's not going to help. 32 multiplied by negative 2x gives us an x term. That's also not going to help. But 32 multiplied by 3 over 2 x squared will give us an x squared term. 32 multiplied by 3 over 2 gives us 48. So we get 48x squared. Now we can look at negative 80px multiplied by 1 gives us an x term. That's not going to help. But if we multiply by negative 2x, we're going to get another x squared term. Negative 80 multiplied by negative 2 gives us positive 160. Then we have px squared. Now we can look at 80p squared x squared. The only way to get an answer that has an x squared term is to multiply this by the constant 1. So this remains as positive 80 p squared x squared. And the question tells us that when we add these three terms together, we get 93x squared. This means that 48 plus 160p plus 80p squared is equal to 93. And now we have a quadratic that we can use to solve for p. So let's rewrite this in descending exponents. We have 80p squared plus 160p. Let's move 93 to the left. 48 minus 93 gives us negative 45. We can make this equal to 0. Again, let's use the quadratic formula to solve for p. We can say p is equal to negative b, negative 160, plus minus b squared, 160 squared, minus 4, multiplied by a, 80, multiplied by c, negative 45, under a square root, all over 80 multiplied by 2, which is 160. Now we can take a calculator and we're going to say 160 squared minus 4 multiplied by 80 multiplied by negative 45 is equal to, it's square root, and we get 200. Now I can say p is equal to negative 160 plus or minus 200 all over 160. Now let's find the positive value of p. We can say negative 160 plus 200 divided by 160 is equal to 1 over 4. So p could be equal to 1 over 4. Now let's find the negative value of p. Negative 160 minus 200 divided by 160 is equal to negative 9 over 4. So p could be equal to negative 9 over 4. The equation of the curve is 2x squared minus kxy plus 2 is equal to 0. And the equation of the line is y is equal to px plus 3, where k and p are constants. given that k is equal to 2 and p is equal to 11, find the coordinates of the points of intersection of the curve and the line. The first thing we need to do is substitute 2 into our k value and 11 into p. So we can write the equation for the curve as 2x squared minus 2xy plus 2 is equal to 0. For the equation for the line, y is equal to 11x plus 3. Now, at the points of intersection, these two equations are equal, which means y in this equation is equal to this y. So to solve for x, we can substitute 11x plus 3 into y over here. So we can say 2x squared minus 2x, open a bracket, the equation for the line, 11x plus 3, close the bracket, plus 2 is equal to 0. And now we can expand the bracket. You have 2x squared, negative 2x multiplied by 11x gives us negative 22x squared. Negative 2x multiplied by 3 gives us negative 6x. Then we have plus 2 is equal to 0. Now we have two square terms. So let's add like terms. 2 minus 22 gives us negative 20. It becomes negative 20x squared. Then we have minus 6x plus 2 is equal to 0. When using a quadratic equation to solve for x, it's a good idea to make your x term positive, which means that we need to change the signs of the terms in our equation. We're going to get 20x squared plus 6x minus 2 is equal to 0. The easiest way to solve for x is to use the quadratic formula, because this way we don't need to simplify our equation. So we can say that x is equal to negative b is 6, so we say negative 6, plus minus b squared, 6 squared, minus 4 multiplied by a is 20, we say 20, multiplied by c, negative 2, under a square root, all over 2 multiplied by a is 20, 2 multiplied by 20 gives us 40. And now you can use your calculator to find the value under the root. So we can say 6 squared minus 4 multiplied by 20 multiplied by negative 2 is equal to 196. Let's square root and we get 14. So now we can make some space and we know that x is equal to negative 6 plus or minus 14 over 40. Now we can find the positive value of x. So we can say negative 6 plus 14 divided by 40 is equal to 1 over 5. So x could be equal to 1 over 5. Now I can find the negative value of x. So I can say negative 6 minus 14 divided by 40 is equal to negative 1 over 2. So x could be equal to negative 1 over 2. These are the x coordinates of the points of intersection, but we still need the y coordinates. And to find y, you can substitute your x coordinates into either equation that you've been given, but always use the simpler one. It just makes everything easier. So we're going to use the equation for the line. Y is equal to 11x plus 3. Let's find y when x is 1 over 5. You can say y is equal to 11 multiplied by 1 over 5 plus 3. Now you can take your calculator and we say 11 multiplied by 1 over 5 plus 3 is equal to 26 over 5. So when x is 1 over 5, y is 26 over 5. Now we need to find y when x is negative 1 over 2. So we can say y is equal to 11, open our bracket, negative 1 over 2, close the bracket, plus 3. Now you can take your calculator. We say 11, open a bracket, negative 1 over 2, close the bracket, plus 3 is equal to negative 5 over 2. So when x is negative 1 over 2, y will be negative 5 over 2. And we have now found the x and y coordinates for the points of intersection. Given instead that p is equal to 4, find the set of values of k for which the curve and the line do not intersect. When we are working with questions like this, and a curve and a line, or even two curves that intersect, we need to use the discriminant. B squared minus 4ac. In this case, the curve and the line do not intersect, which means that our discriminant will be smaller than 0. To find the values a, b, and c for the discriminant, we need to make our given equations equal. So the equation for the curve, 2x squared minus kxy plus 2 is equal to 0. P is now 4, so the equation for the line becomes y is equal to 4x plus 3. These equations are equal, which means y over here is equal to y over here. And just like we did in part A, we can substitute 4x plus 3 into the y value in the curve. So we can say 2x squared minus kx, open a bracket, 4x plus 3 plus 2 is equal to 0. Now we can expand our brackets. We get 2x squared minus 4kx squared minus 3kx plus 2 is equal to 0. Now we have a quadratic equation that is equal to 0. And from this, we can find our a, b, and c values. A is the coefficient of the square term. Here we have two square terms. So a is both coefficients, 2 minus 4k. B is the coefficient of the x term, which in this case is negative 3k. And c is the constant, which in this case is 2. Now we can put these values into the equation for the discriminant. I'm going to make some space. B is negative 3k, so we get negative 3k in a bracket squared, minus 4a, so let's open a bracket. A is 2 minus 4k, 2 minus 4k, multiplied by c, which is 2. Put this into a bracket as well. Now we need to expand our brackets. Negative 3k squared gives us positive 9k squared. Now we need to expand negative 4 multiplied by 2 brackets. Our second bracket has a 2. So the easier way to do this is to say negative 4 multiplied by 2, which gives us negative 8. And now we multiply by the terms inside this bracket. Negative 8 multiplied by 2 gives us negative 16. Negative 8 multiplied by negative 4k gives us positive 32k. I always find that it's easier working with quadratics when our exponents are in descending order. So let's rewrite this as 9k squared plus 32k minus 16. This is the equation for the discriminant, so it will be smaller than 0. But because we're working with a quadratic, we need to find our critical values, which means that we need to make this equation equal to 0. So I'm going to take out the smaller than sign and make this equal to 0. To solve for k, let's use the quadratic formula. I can say k is equal to negative b. b is negative 32. So negative 32 plus or minus b squared, 32 squared, minus 4, multiplied by a, which is 9, multiplied by c, negative 16, close the bracket, under a square root, all over 2 multiplied by 9, which is 18. Now we can find the values under the root. So let's take our calculator, and we say 32 squared minus 4 multiplied by 9 multiplied by negative 16, close the bracket, is equal to 1600. Let's square root, and we get 40. So k is equal to negative 32 plus or minus 40 all over 18. Let's clean this up a little bit. I'm going to rewrite my equation. K is equal to negative 32 plus or minus 40 over 18. Let's find my negative value for k. I can say negative 32 minus 40 over 18 is equal to negative 4. So k could be equal to negative 4. Now let's find the positive version. Let's say negative 32 plus 40 divided by 18 is equal to 4 over 9. So k could be equal to 4 over 9. But these values of k make the discriminant equal to 0. And we don't want a discriminant equal to 0. We want a discriminant smaller than 0. So let's rewrite the equation for the discriminant. We have 9k squared plus 32k minus 16. And we need values of k that make this negative. So we need to find a value that makes the equation negative. And remember that when you are working with a quadratic, our critical values make the equation 0. If the values between these two make our equation positive, the outside values will make the equation negative, and vice versa. So a good thing to do is to test a value, in this case between negative 4 and 4 over 9. Use the simplest value, which in this case is 0. So if k is 0, 9 times 0 is 0. If k is 0, 32 0 is 0. So we have 0 plus 0 minus 16, which is smaller than 0, which means that in this case, we have to consider values that are greater than -4, but smaller than 4/9. So the final answer, we can say -4 is smaller than k, which is smaller than 4/9. The equation of a curve is y is equal to 4x squared plus 9/x squared minus 8. A point P is moving along the curve in such a way that its y-coordinate is decreasing at 5 units per second. Find the rate at which the x-coordinate of point P is changing when x is equal to 2. When working with rate, we can use the chain rule. dy over dx is equal to dy over dt multiplied by dt over dx. When we write a value for a rate, it is always within a fraction over dt. So in this case, the y-coordinate is decreasing at 5 units. This is the rate of y. So we say dy over dt. It is decreasing, which means the rate is negative. So it's equal to -5. Find the rate in which the x-coordinate is changing. So we need to find dx over dt. This is our unknown value. We can use the chain rule to find an unknown value as long as we have 2 known. In this case, we have dy over dt, but we need dy over dx. So the first thing we need to do is we need to find the derivative of this equation over here. It's difficult differentiating equations where you have x terms in the denominator of a fraction. So the first thing we need to do is to change this fraction and give it an x term with a negative exponent. So we can rewrite this as y is equal to 4x squared plus 9x with an exponent of -2 minus 8. And now we can find dy over dx. You can say dy over dx is equal to 2 times 4 is 8. This becomes 8x. -2 multiplied by 9 is -18. This becomes -18x with an exponent of -3. And our constant falls away. So this is the equation for the derivative. The question tells us that x is changing when x is equal to 2. So to find the value of dy over dx, we need to substitute 2 into our x values. So you can say dy over dx is equal to 8 multiplied by 2 minus 18 multiplied by 2 with an exponent of -3. And you can put this whole equation into your calculator. So 8 multiplied by 2 minus 18 multiplied by 2 with an exponent of -3. And we get 55/4. This is the value of dy over dx. Let's make a note of this over here, 55/4. So now, in our chain rule, dy over dx is 55/4. And this is now equal to dy over dt, -5, multiplied by dt over dx. But the rate of x is dx over dt. So we need to multiply both sides by dx and divide both sides by dt. So on the left, I'm now going to have dx over dt is equal to -5. Let's move 55 over 4 to the right. To make it easier, let's just divide by 55 over 4. Now you can take your calculator and we say -5 divided by 55 over 4 is equal to -4 over 11. This is the rate that x is changing. Find the coordinates of the stationary points of the curve and determine their nature. Now in part A, we've already found that the equation for dy over dx is equal to 8x minus 18x with an exponent of -3. At the stationary point, the equation for the derivative is equal to 0. So let's make this equal to 0. And now we can find the x coordinates of these points. Because we're solving for x, I'm going to rewrite this as 8x minus 18 over x cubed. And this is now equal to 0. To solve for x, let's move the fraction to the right. I'm going to get 8x is equal to 18 over x cubed. Let's multiply the x out and we get 8x to the power of 4 is equal to 18. To get x by itself, divide both sides by 8. And we see that x to the power of 4 is equal to 18 over 8. Now to find x, you can take your calculator and we can say root 4 18 over 8 is equal to 1,224, but we can't get a fraction to this value, and it becomes a little bit more difficult when we have x values with so many decimals. So in a case like this, what is easier is to square root first, and then we'll see if we need to square root our answer. So let's square root 18 over 8. And we get 3 over 2. If we square root again, we get root 3 over 2. So in this case, x could be equal to positive or negative, let's write this over here, 3 over 2 under a square root. Now that we have x, we can look at our possible y values. So let's make some space. And up here, I'm just going to make a note that our x values are positive or negative 3 over 2 under a square root. To find the y coordinates, we substitute our x value into x in the equation. So we can say y is equal to 4 multiplied by 3 over 2 under a square root squared plus 9 over 3 over 2 under a square root squared minus 8. When you have a square root and a square, they cancel each other out. So this becomes 4. The root and the square will cancel. So we get multiplied by 3 over 2 plus 9 over the roots and the square cancel, 3 over 2 minus 8. 4 times 3 is 12, over 2 gives us 6, plus 9 divided by 3 is 3, multiplied by 2 gives us 6, minus 8. 6 plus 6 is 12, minus 8 gives us 4. If we were to substitute the negative root into our brackets and square them, the answer would still be 3 over 2, which means that 4 is the y coordinate for both of our points. So for our first point, let's do the negative root, 3 over 2 under a root with a y coordinate of 4. And our positive root, 3 over 2 under a square root with a y coordinate of 4. But we still need the nature of these roots, which means we need to find the second derivative. Let's quickly rewrite down the equation for the first derivative. dy over dx is equal to 8x minus 18. I don't want to work with a fraction, so I'm going to write this as x with an exponent of negative 3. And now I can find my second derivative. D squared y over dx squared is equal to, my x term becomes my constant, so we get 8. Negative 18 multiplied by negative 3 gives me positive 54. So I get plus 54 x with an exponent of negative 4. Now I can determine the nature of my roots. And to do this, I need to substitute the x coordinate of my stationary points into this equation over here. So I'm going to have 8 plus 54, open bracket. Let's look at the positive x value first. 3 over 2 under a square root with an exponent of negative 4. And I can put this straight into my calculator. 8 plus 54, open a bracket, the square root of 3 over 2, close the bracket, make sure that your bracket is outside of your root, with an exponent of negative 4. And we get 32. 32 is greater than 0, which means that this is a minimum turning point. But if I were to input negative root 3 over 2 into my equation, I would still get an answer of 32. So in this case, both of my stationary points are minimum points. The circle with equation x squared plus y squared minus 6x plus 10y minus 27 is equal to 0 intersects the line x is equal to negative 2 at the points P and Q. Find the area of the triangle formed by the tangents to the circle at P and Q and the line x is equal to negative 2. In this question, we need to find the area of the triangle. And a good place to start is to try and get a general idea of the triangle that we're working with. We are working with a circle. So let's draw a diagram which intersects the line x is equal to negative 2. I can put this in over here. This is one side of our triangle. The other two sides are formed by the tangents to the circle at P and Q. So to get an idea of what the tangents look like, let's start by finding the coordinates of P and Q. The question tells us that at these points, the line x is equal to negative 2 intersects the equation for the circle. So the x coordinates of both point P and point Q will be negative 2. So let's find the y coordinates. And to do this, we can substitute negative 2 into the x values in the equation for the circle. So we can say negative 2 squared plus y squared minus 6 multiplied by negative 2 plus 10y minus 27 is equal to 0. Negative 2 squared is 4 plus y squared. Negative 6 multiplied by negative 2 gives us positive 12 plus 10y minus 27 is equal to 0. Now we have a quadratic. So let's tidy this up. We have y squared. We have one y term, so plus 10y. 4 plus 12 is 16, minus 27 gives us negative 11, and this is equal to 0. The value of y will give us the y coordinates of P and Q. So to solve for y, let's factorize. We have two brackets with y. 11 only has two factors, 11 and 1. 10 is positive, which means we have y plus 11 and y minus 1, which is equal to 0, which means that y could be equal to negative 11, or y could be equal to 1. This means that our points have coordinates negative 2 and 1, and negative 2 and negative 11. Let's say that P is the higher coordinate. We can plot this on our diagram, and let's fill in the coordinates. Q lies lower, so let's plot Q, and we can put in the coordinates as well. The area of the triangle is bounded by the tangents to P at P and at Q. So to draw a triangle, we need to know where these tangents lie. To find the equation of a tangent, we need one point and the gradient. But remember that tangents are perpendicular to the radius. So to find the gradient of these tangents, we need the gradient of the radius. And to find the radius, we need the center of the circle. Remember that in this form, we can use the x and y terms to find the center of the circle. The coefficient of x will help us find the x coordinate. To find the x coordinate, we take the coefficient, negative 6, divide by 2, you get negative 3. Change the sign, and we get positive 3. This is the x coordinate of the center. For the y coordinate, we take the coefficient of y. Divided by 2 gives us 5. Change the sign, we get negative 5. This is the center of our circle, and we can put this into our diagram over here. Now I can use the gradient formula to find the gradient of radius PC. So I can say the gradient of radius PC is equal to, let's make P 0.1 and C 0.2. So I'm going to say negative 5 minus 1 over 3 minus negative 2, which gives me negative 6 over 5. The tangent is perpendicular to the radius. So to find the equation of the tangent, all I need to do is turn the fraction upside down and change the sign, which means the gradient of tangent P must be positive 5 over 6. Now I've got a gradient and the coordinates of 1 point. So I can find the tangent using the equation for the straight line. Y is equal to mx plus c. My y coordinate is 1, so I can say 1 is equal to m 5 over 6 multiplied by x, negative 2, plus c. Now I have 1 is equal to negative 10 over 6 plus c. To find c, we're going to move this to the left. 1 plus 10 over 6 is equal to c. And we see that c is equal to 16 over 6. Simplify, and we get 8 over 3. Now let's make some space, and I can draw in tangent P over here. Now I need tangent at Q. So I'm to find the gradient of the radius QC. So I can say MQC. Let's say that Q is my first point and C is my second. So I can say -5 minus -11 over 3 minus -2. And I get 6 over 5, which means that the gradient for the tangent at Q must be -5 over 6. And now I can find the equation. Y is equal to mx plus c. And now I'm going to substitute the x and y coordinates of Q into my equation. -11 is equal to m -5 over 6, close the bracket, multiplied by -2 plus c. -11 is equal to +10 over 6 plus c. Let's move the fraction to the left. -11 minus 10 over 6 is equal to c. To make this easier, let's take the calculator, and I can say -11 minus 10 over 6 is equal to -38 over 3. C is equal to -38 over 3. And now I can draw in my tangent at Q. Now I've got a general idea of what my triangle will look like. But when working with coordinate geometry, we don't need to use trigonometric ratios and cosine and sine rules to find the area. We can use the basic half times base times perpendicular height. In this case, the base will be the distance between P and Q, and the height will be between line x is equal to -2 and the point of intersection of the two tangents. So let's make this red. To find the height, we need to find the point of intersection. For tangent P, we know that the equation is 5 over 6 x plus 8 over 3. And for tangent Q, -5 over 6 x minus 38 over 3. And we can use this to find the value of x. Let's move -x to the left. 5 over 6x plus 5 over 6x is equal to -38 over 3 minus 8 over 3. Now I have 10 over 6x is equal to -38 minus 8 gives me -46 over 3. To get x by itself, let's divide both sides by 10 over 6. X is equal to -46 over 3 divided by 10 over 6. And I can put this straight into my calculator. I can say -46 over 3 divided by 10 over 6 is equal to -46 over 5 is equal to -46 over 5. But fractions like this, they're not great to work with. So let's see, a decimal is much easier. -9,2. And now I can make some space. This is the x coordinate of my red point, -9,2. Now I have enough information to find the base and the perpendicular height. The base of the triangle is the blue vertical line, where x is equal to -2. So the length of the base is the distance between our y coordinates. So for the base, I can say base is equal to 1 minus -11, which gives me a length of 12 units. The perpendicular height is the distance along the x-axis between x is equal to -2 and -9,2. So I can say the height is equal to -2 minus -9,2, which is equal to 7,2. Now that I have the base and the height, we can find the area. So we can say the area is equal to 1/2 multiplied by base, which is 12, multiplied by perpendicular height, 7,2. Take your calculator. 1/2 multiplied by 12 multiplied by 7,2 gives us 216/5. And we can say the area is equal to 43,2 units. The diagram shows a sector ABC of a circle with center A and radius r centimeters. The angle BAC is alpha radians, where alpha is greater than 0 but smaller than 1/2 pi. It is given the area of the triangle ABC is 4 square centimeters, and the area of the sector ABC is 8 alpha centimeters squared. Find the exact area of the shaded segment. When exam questions ask you for the exact area, you can still leave your answer in terms of pi. But in this case, we cannot leave our answer in terms of alpha or of r. So before we can find the shaded segment, we need values for alpha and for r. So let's make some space. We have two unknown variables, and when we need to solve for two unknown variables, we need to use simultaneous equations. The question tells us that the area of a triangle is 4 centimeters squared. Let's start with the formula. So we can say the area of a triangle is 1/2 AB sine C. A and B are the radius r. So this becomes 1/2 multiplied by r multiplied by r again. So we get r squared sine the given angle, which is alpha. And we can see that this is equal to 4. The area of a sector takes on the equation 1/2 r squared multiplied by the angle, which in this case is alpha. We know the area is 8 alpha centimeters. Let's say 8 alpha. This equation has an alpha on both sides, so we can cancel them out, and we get 1/2 r squared is equal to 8. Now we can use this to find r. Let's multiply both sides by 2, and we see that r squared is equal to 16, which means that r must be equal to 4. R is a radius, it's a length, so we only ever consider the positive root. Now that we know that r is 4, we can use the equation for the triangle to find alpha. So we can say 1/2 multiplied by 4 squared multiplied by sine alpha is equal to 4. 4 squared is 16, divided by 2 gives us 8. So we get 8 sine alpha is equal to 4. Divide both sides by 8. sine alpha is equal to 4 over 8, and we can simplify to 1 over 2. Now you can use your calculator to find alpha, but please remember that when working with circular measure, our angles are in radians. So let's take our calculator. Let's go to radians. Now we can say shift sine 1 over 2, close the bracket, is equal to 1 over 6 pi. This is the size of angle alpha. Now that we have alpha and r, we can find the shaded segment. So let's tidy this up. The shaded segment consists of the area of the sector less the area of the triangle. And we already know that the area of the triangle is 4 centimeters squared. So all we need to do is find the area of the sector. So I can say the area of the sector is equal to 1 over 2 r squared alpha, which is equal to 1 over 2 r is 4. This becomes 4 squared. Alpha is 1 over 6 pi. So I can say 1 over 6 pi. And you can put this whole thing into your calculator. So we can say 1 over 2 multiplied by 4 squared multiplied by 1 over 6 pi is equal to 4 over 3 pi. Four over 3 pi is the entire sector. So to find the shaded area, all we need to do is subtract the area of the triangle. So I can say shaded is equal to 4 over 3 pi minus 4. And you can leave your answer in terms of pi. If you'd like to leave it in decimals, the area is 0,189 to 3 significant figures. Part B says it is given instead the length of chord BC is now 1 over root 2 r centimeters, but the area of the triangle ABC is still 4 centimeters squared. Find the area of the shaded segment. Give your answer correct to 3 significant figures. Chord BC has now changed, but the area of the triangle is still the same. This means that our angle alpha has changed and the length of our radius r has changed. So to find the shaded segment, we now need to find new values both for r and for angle alpha. So let's make some space so we can make some notes. The question tells us that the area of the triangle is still 4 centimeters squared. So let's make a note and we can say the area of the triangle, which we know is 1 over 2 r squared sine theta, which in this case is sine alpha, is still equal to 4. But our r value and our angle alpha are now different, which means that the total area of the sector is no longer 8 alpha. We need to find these new values. When you are given the chord, one side of this triangle here, the best thing to do is to use the cosine rule. A squared is equal to b squared plus c squared minus 2bc cos A. In this case, I'm going to use chord BC as side A. So I can say BC squared is equal to, I'm going to use the radius r for sides B and C. So I can say r squared plus r squared minus 2 multiplied by r and r again. So I get r squared cos my angle, which in this case is alpha. BC, we now know is 1 over root 2 r. So I'm going to write this as 1 over root 2 r, put this into a bracket, squared, is equal to r squared plus r squared gives me 2r squared minus 2r squared cos alpha. On the left, let's expand the bracket. 1 squared is 1. Square root of 2 squared gives me 2. So I have r squared is equal to, on the right, I have 2 terms with r squared. So let's take them out as a common factor. I have r squared, open my bracket, 2 minus 2 cos alpha. And now these r's will cancel out. And this is going to allow me to find the value of alpha. Let's make some space. On the left, I now have 1 over 2 is equal to, on the right, 2 minus 2 cos alpha. To find alpha, my trigonometric ratio has to be positive. So let's move this to this side. So I have 2 cos alpha is equal to, on the right, I have 2. Let's move 1 over 2 to the right. So I'm going to subtract 2. 2 minus 1 over 2 leaves me with 3 over 2. To get alpha by itself, to get the ratio by itself, let's divide both sides by 2. And I get cos alpha is equal to 3 over 2 divided by 2, which is 3 over 4. Now I can use my calculator to find alpha. So I can say shift cos 3 over 4, close the bracket, is equal to 0,22734. Let's write this as 0,7224. Be careful rounding off while you're still calculating, as this can affect your final answer. Now that we've got alpha, we can find the new value of r. And we can use the equation for the area of a triangle. 1 over 2 r squared sine alpha, which is still equal to 4. Now I can say 1 over 2 r squared sine, instead of alpha, 0,7224, and this is equal to 4. To find r, I need this term to be by itself on this side of the equation, which means I need to move everything else to the right. Let's multiply both sides by 1 over 2. So on the right side, I'm going to get 4 multiplied by 2, which is 8. Let's divide both sides by my ratio. So I'm going to say 8 over sine 0,7224. And on the left, I have r squared. Now I can take my calculator. Let's move this a little bit that way. I'm going to say 8 over sine 0,7224, close the bracket, is equal to 12,099. But remember, this is the value for r squared. I want the value for r. So while we have the calculator, let's square root. The square root answer is equal to 3,478. So r is equal to 3,478. Now I have a value for alpha and a value for r. So now I can find the shaded segment. Just like we did with part A, to find the shaded segment, we find the area of the total sector and we subtract the area of the triangle, which we know is 4. So let's find the area of the sector. We use the formula 1 over 2 r squared multiplied by alpha. We get 1 over 2. R is 3,478. Put this into a bracket, squared, multiplied by alpha, 0,7227. Close the bracket. Let's take our calculator. 1 over 2. Open a bracket, multiplied by 3,478 squared. Open another bracket, multiplied by 0,7227. Close the bracket, is equal to 4,37106. This is the area of the whole sector. To find the shaded section, all we have to do is subtract the area of the triangle, which we know is 4. You can say minus 4 is equal to 0,37106. The question tells us to leave our answer to 3 significant figures. So as our final answer, we can say 0,371. The functions of f and g are defined by f of x is equal to root x and g of x is equal to 3 root x plus 2 minus 5. Describe fully a sequence of transformations which transform the graph of y is equal to f of x to the graph of y is equal to g of x. Should make clear the order in which the transformations are applied. The order of transformations. First, we always look at horizontal stretch parallel to the x-axis, then vertical stretch parallel to the y-axis, and then translation. That's movement either up or down or left and right. F of x is equal to root x. G of x is equal to 3 root x. 3 is our a value. This affects the vertical stretch parallel to the y-axis. This is our first transformation. So in your answer, you can say a stretch of scale factor 3 parallel to the y-axis. Now we can look at translations. F of x is equal to root x, but g of x is equal to the root of x plus 2. 2 is our p-value, which affects the horizontal movement along the x-axis. 2 is positive, which means that g of x is shifted 2 units to the left. We also have negative 5. This is our q value, which means that g of x shifts 5 units downwards. So as your answer, we can say that there is a translation, negative 2, negative 5. The diagram shows the graph of y is equal to g of x. Part B says on the diagram, sketch the graph of y is equal to g to the negative 1x, together with any relevant mirror line. We are being asked to sketch the graph of the inverse function. When working with inverse functions, your mirror line will always be a graph with the equation y is equal to x. So the best place to start is to draw in your mirror line and label it as well. This shows your marker exactly what you're trying to do. And now we can sketch the inverse function. When sketching, you do not have to plot any points or any coordinates. You just need to give a general idea of where the inverse function will lie. Remember that the domain of a function is the range of the inverse and vice versa. So here we can see that g of x has an x-intercept where x is positive, which means the inverse will have a y-intercept where y is positive. It has a y-intercept where y is negative, so the inverse will have an x-intercept where it is negative. And you can sketch your graph like this. Remember to label your graph as well, as without this you may lose a mark in your exam. Find an expression for g to the negative 1x. To find the equation of an inverse function, a good place to start is to write the equation of the original function with y as the subject. So instead of g of x, we're going to say y is equal to 3x plus 2 under a square root minus 5. Now we swap the x and y terms around. So we get x is equal to 3y plus 2 under a square root minus 5. Now we need to make y, this y, the subject of the equation. So let's move negative 5 to the left. Get x plus 5 is equal to 3y plus 2 under a root. To get y by itself, we need the root to be by itself. So we need to divide both sides by 3. So x plus 5 over 3 is equal to y plus 2 under a root. Next, we need to get rid of the root, so we can square this side, which means we square this side. And on the left, we now have x plus 5 over 3 in a bracket squared is equal to, on the right, the root and the square will cancel. We have y plus 2. Finally, we have to move 2 to the left. I'm going to write this up here. We now have x plus 5 over 3 squared minus 2 is equal to y. This is the equation of our inverse. So we can say g to the negative 1x is equal to x plus 5 over 3 in a bracket squared minus 2. Part D says state the range of the inverse of g. Now remember that the domain of an original function, g of x, is the range of the inverse and vice versa. And the question tells us that g of x considers x values greater than or equal to negative 2. This gives us the range of the inverse. So we can say that y is greater than or equal to negative 2. Find the value of g to the negative 1 h4. Here we have a composite function, and the best place to start in this case is let's find h of 4. The question tells us that h of x is equal to x minus 2. So I can say h of x is equal to x minus 2. For h of 4, we substitute 4 into x. 4 minus 2, which is equal to 2. Now we can substitute 2 into the inverse function of g. We know that g to the negative 1x is equal to x plus 5 over 3 squared minus 2. Let's substitute 2 into our x value, and we get 2 plus 5 over 3 squared minus 2. And you can put this whole thing straight into your calculator. Let's open a bracket. We can say 2 plus 5 over 3, close the bracket, squared, minus 2 is equal to 31 over 9. This is our answer.